here.
I did
How
3
many
for that.
sections are we going to get?
3, miss.
Yes, I said 3, you know.
Alright, and it don't matter which way you choose to divide the section, but I am going to do it smarter as opposed to having more sections. You will get the same answer at the end, so I'm going across there, and then I'm going across here. And I tend to...
What if you did it the other way around?
Same answer you're going to get, it's just that you're going to have more, because if you went down this way, what will happen? Yeah. You will have 1 here, 1, 1. Good? Oh. So the same 3 section you might have. So it just, it really don't matter where you decide to do it, answer will be the same. So I have section 1, and this is going to be my section 2, and this is going to be my section 3. Yes? So now you know we need to find area 1, area 2, and area 3. Oh, I didn't give you any unit for this one. Let's use millimeters since the figures are so large. If you use something else, it's fine. Same values we're going to get. All right, so let's look at 1, section 1. What's the values that we're going to work with? A1 is going to be equal to 80 mm times 20 mm. So that's going to be equal to 1600 mm square. Yeah? And then that's what you have. I'm curious, are you hearing me? That's what you have? Bear in mind, my section 1 might be your section 3. Are you still hearing me, students?
Yes, miss. Yes, miss.
All right, good. So for 2, what do you have? What's the value for area 2? So we have 25 times what?
Oh, 90. I'm 90. I'm new to that. I'm not sure.
90. Alright, so that's 250. And then our third one, we have the 60 mm times our 30 mm. So that's going to be equal to 1800 mm.
Right. Yeah.
So that's 1800. So now you need your total area. So let's just add these. I add the same thing. I copy the same thing. And we're copying this one there plus u. And when you sum that, you're going to get 56550 mm square. So now we know we're going to have x1 and we're going to have x1, y1, x2, y2, and we're also going to have x3 and we're going to have y3. So let's look at 1 first. This section right here. What's going to be my x value? What's going to be my x value? Thank you a lot. A section 1 right here. What's the x value? Remember, it's from the face of the object.
80. This will be 80.
Yeah, it's going to be 80. My x value for my center of gravity, for my CG.
40.
Oh, 20, miss. From the 20.
Look at it carefully. Half of it. Remember, it's rectangle, so it's half of it. So this is 80, you know, so it's going to be half of that.
Crap.
So
Yes, miss. It would be 40. It would be half of the 80.
Yes.
Yeah.
What would be my y?
Sorry.
That's fine.
10.
What would be the y? 10 mm. Good. So look at now at x2. What will be x2? Alright.
12.552.
I see 12.5 But I hear times 2 what?
5.
No, for area 2.
5.
Oh, for area 2. Good. So what will be my y value?
That'll be 20 plus 45, so 65.
All right. So okay, good. You correct yourself. 65 mm. Look. So half of this will be 45, but then you're going to the base, right? So it will have to be plus 20. So that will give you your 65. So for my x3, what's my distance now on the x plane? For my center of gravity?
30.
30.
So it's going to be 30 mm. What's the y3?
125.
125.
All right. Make sure you note that carefully. Look at it. Okay. Hold on. Let me check this chart. All right. So 30. Look at how we got the 125. Look. So half of it is 15 plus the 90 plus the 20. Good. All right then. So we have all of those values laid out. So the next step now is to find area. What happened, Mama? Okay, Mommy. All right. So let's find the area. Our total area was 5,650. So let's plug it right there. I'm just going to delete the little things on the top. Oh, you know we're finding y. All right. And we are going to have another section here. We're going to have area 3. So this is 3 and this is 3. So our area 1 was 1600. Let's put it right here. Our y1 is 10. Let's copy that. Put it here. And then we have area 2. Put it here. Times what? y2. And you need another section, of course. So our area 3 times our y3. And after that, all you're doing is plugging in your information now. So 1600 times that. 16,000 mm cube. 2,250 times 65. Check the answer. So I'll type my answer and you just check to make sure it's correct.
46,250.
Alright, good. And then we have wrong thing I copied.
Madam.
225.
Yes, miss.
000. Alright, add them together and tell me how much we have working with.
691.
387,250.
Okay. Wait, all of these need to change. My thing right here need to change. Hold on. You need to change. Don't confuse anybody right here. You need to change as well. And I just need to underline you back. And you need to change. Both of them. Alright, so what is y? When we work out y, how much is that?
68.53.
Yeah, 68.539.
5398.
Yeah, there. Yeah.
And then you round it off to 69. Okay? That means from your base, the center of gravity, the CG for this will be position 69 on the vertical plane. So let's work out our x. Good? Dun, 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 dun. 1 second. Copy you. Boys better copy everything and change the x. All right. Down for you. So this is going to be what? This is supposed to be x1, x2, x3. And now we're finding x. Let me just put capital X. Good. So I don't have to change those other little ones, right? Little one right there. So what is our x1 value? Remember our x1 was 40 millimeter. So right here where we have the 10, change to, that's 40. Our x2 was 12.5. So right here where we have that 65, 12.5. And our x3, 30. So right here is going to be 30. All right, let's plug those in and see the values that we have working with. Yeah. So what do we have? 64,000. Check that value for me, please.
Yes, miss. 64,000.
28,125.
Yes, miss.
And then 54, right? 54,000. All right. So let's sum it now and see what we have. 146, 125. And how much did we get? This is what you got?
35.862.
Okay. And we round it up to 26. Yeah? So that's how you will work out those. Good. Seems as if you understand for the most part. Now with this one, notice you are not given your center, you're not given a point of application for this. So when you're not given that point of application in this instance, you have to choose a point. Typically when you're working this system, you choose the point referencing to the first point, which is in this case A, first point on it, right? So it's either the first point or the last point, so you can move from one end of the system to the other end. So this, you could label them A, B, C, and I could choose C as well and move from C to A, or I use A and move forward. You don't use the, just start with the one in the middle. Hence why this is not factored in. So you will see here where you're given the distance, and this is to the center. So you see this A that I just put right there? It's in the center of circle 1. Now, first thing you have to do is find the weight, which is the load. And you will do that by adding all the loads given. Sometimes the loads are not given in the same unit, and you will have to convert some of them. So I could tell you 100 Newton, 50 Newton, and then just say 25 kilonewton. Right? Because you had 2 Newton before, it means that you would convert from the kilonewton to the Newton, or you'd have to convert everything to kilonewton, but you have to work with like units. That's the first thing. So now we would have 100 Newton, being that they're the same unit, plus 50 Newton, plus 25 Newton. So the load right here is going to be 175 Newton. That's the first thing. Determining the load, the total load on this system. Good? After that, you're going to be taking moments, and you're going to take moments about that pivot point that you have chosen. In this case, I'm choosing A right here to be my pivot point. Good? So, you might ask, you are choosing, when you're doing any design, when you're doing any structure, ideally is the engineer and the drafter and the designer choose where the loads are applied and so forth. So yes, we're choosing that is going to be the point of application. So moments, we're going to take moments about A, that point A that I've selected. And we're going to say let X, and X, remember that you're seeing where they're in one plane. They're in the horizontal plane. So if I should draw a line through the center of A, good, they will all line up along that line. Good. So they're in the horizontal plane, which is the X. So we're going to let X equal the CG from the CG distance you should have from A. So moments about A, and you're letting X be the CG distance from A. So we know our total load. Our total load is 175 Newton times X that we're trying to find. Yes? And then we're going to take moments now. So for A, we have 100 Newton, and I'm just writing this down. Typically, you just ignore it when you're working out your calculation. Times 0 meters. You know why that is 0? Because the pivot point is right where the 100 Newton force is. So you don't have any distance. So moments can't take place right there, no true? So you ignore that. Now here you have 50 Newton times, what's the distance from A?
10 meters.
Meters.
10 meters. Plus, what's the next force we have? 25 Newton?
Yes.
Times, what's the distance from A?
18.5 meters.
18.5 meters. Alright? Read. Earlier, this is one that you say you don't remember. You remember it now?
It's me sketching it.
Alright, that's what I want to hear. So this is 0. So this don't exist, you know. But we're still putting it there so you can follow the steps. Alright? And then we're going to have, what's this going to be? 500 Newton meter. And then what's the next one going to be?
462.5.
0.5 Newton meter. And then you add them. So when you add them, how much Newton meter is that?
962.5.
0.5 Newton meter. Good. And we're trying to find X, yeah? So we're going to have to divide both sides by that 175 right there. 175 Newton. Let's be clear. 175 Newton. We can't just drop the unit and say it don't exist, because it actually exists. That's how we're going to get distance, because look what happened. With this now, when I come over here and I say 175 Newton, you see the Newton cancel the Newton, so I am left with X is equal to meter as the unit. And what's the value? How much do you get when you divide it?
5.5 meters.
5.5 meters. So you just write your little note to say CG is on the line, because you'll have to label it, you know. In this case I didn't label it, so you could say ABC, because we're saying ABC, that's the first thing. Or you could just say, if it's two of them, AB, you could use the 2N1, AC, whatever. Right? You're just going to label it to say it's on the line ABC in this case, at a point 5.5 meters from A. You could even go, it is on the horizontal line if you want to be so specific, but it's clear that it's on the horizontal line. Or you could say it's on the x-axis at a point of such from A. And that is how you would work out the CG for this. Alright? Chris? Got it? Number 3?
Yes, miss.
Alright, so now let's see if we can go into inertia. So let's close this and let me share that.
Miss, remember to record it when you start inertia.
I wasn't recording all along.
No, miss.
Oopsie daisy.
I figured probably because you're just going over why you didn't.
I wanted that to be right a part of it. So when you're going through your inertia thing, you could actually remember. But anyways, that's fine. You know how to do it. Alright, so we're going to do Let's save this to the desktop. We're going to be doing Inertia Module 1, and these are the objectives that we will cover. Defining inertia, determining the inertia for simple shapes, just like we did for center of gravity for simple shape. Then we're going to determine the inertia for compound shapes, and then we're going to determine section modulus. So that is tied up in determining inertia. Alright, now if you notice, all of this is really revision because we would have done this in one, but I still have the notes in the inertia point because it's a very short content, but the concept will require you to do longer calculations even though they are simple. Alright, so the CG right there is for you to remember how to go through the different process. We just did some example of this, so we're just skipping through it. Alright, so for moment of inertia, it is really, we call it the second moment of area, and that is because we call center of gravity moment of area or centroid. Good. So you're using moment of inertia to determine the ability of the member to resist bending. Just like when you look at a beam and you say, oh, it's going to fail at this point, that point, and so forth. The inertia value, if it is larger, it is telling you that there is a high chance that the beam will fail along the x-axis, which means the horizontal plane, or along the y-axis, along the vertical plane, if said loads are applied to it. Good. So you're really determining, and this word, emphasis on this word, that's why it is in bold, efficiency of the beam to resist bending. Now we're not talking about the strength of the material, because most times when we say if you want to a member, a structural member, to resist bending or failure, you think about the strength of the material. Inertia is giving you, it's a prediction that will tell you whether or not failure will take place regardless of the material that you're going to use. It's not indicating that the material or the quality of the material is good, yes or no. Right? All it is indicating is failure or the ability to resist failure in either of the two axes. Good. So the same principle that we got used to govern center of gravity, we're going to use it as well because it's a continuation of that. Now here you're seeing I. I is used to denote inertia. So I, the total inertia for a shape, is going to be the inertia plus the area H2. Now you have to know that this H right here, look at how it is broken down along the x-axis and along the y-axis. For x, for example, you will see where you have y minus y. So this y, with the little thing at the top of it, is the distance, the overall distance you will move on the vertical plane to determine the center of gravity for the entire object. Now this one right here is the distance you will move in each section. So you see, earlier we did section, hold on, let me switch back to it a bit, not that. Did I close the one I just did? Earlier, the one that we were looking at, right? Where we had section 1, section 2. This Y would represent section 1, and then you will have to go again and find section 2, section 3. So you have to find inertia in each section. Good? That's the H. These are the values these are the formula that you will use going forward for module 1. You'll use IXX and you will use IYY. Alright? Now, what is inertia? You notice that you don't have a value for inertia right here, which is I. That is because it depends on the shape of the object. Just like in centroid, center of gravity, where we can say that for the rectangle, you find the center of gravity by finding the midpoint of it. Same principle apply. Inertia right here, that I, will have a value or a formula assigned to it depending on the shape. So for example, if I am finding a rectangle about the neutral axis, this is what we will be using at this level, right? About the neutral axis, which means about x and y, this is the formula that you will substitute for I. So 1 over 12 BD cube is for IXX. So if I am finding IXX, Wherever I see this I right here for inertia, I am going to substitute that, and I am going to put 1 over 12 BD cube right here. Good? Same thing applied to the IYY. It's going to be 1 over 12 DB cube. Because they're so close, persons often make mistake with them. You can't do that. IXX, it is 1 over 12 BD cube. Yeah? That's the base times the depth cube. And then for IYY, it is the depth first and then the base cube. It don't matter which order you write it. If you want to write the base first, just ensure that it is cube. Good? If you want to write the depth first, fine. Write the depth, but nothing is assigned to it. And so on. So this is what you have to know about the neutral axis. You can also find it about the edge. If you're finding it about the edge, look at this right here. You will see where you're using UU and VV. Note where the UU and the VV is. Look. So you have UU, and this is along the horizontal plane again. And this is what? VV. But if you notice, UU is at the base, and then VV is where? To the right face. Good? And then you also have other rectangular shapes, such as this one right here, where you'll have to use this formula. So you have to say, this is what you'll use, half 1 over 12, and you notice the BD cube minus BD cube. So the big BD that you're seeing right there is the overall. See it right there? So it's talking about the overall base and the overall depth minus the what? The smaller base and the smaller depth. So you have a larger rectangle and you have a smaller rectangle in it, and you have to subtract those. Right? So that is how you would work out a allosection. Now, for a triangle, look at the triangle right here. Let me zoom in a bit so you can see. You notice right there where it is saying that it is what? BD cube over 36. So look at how you determine x-axis. It is not at the base. The base is considered the neutral. Right? This right there is the neutral axis right down there. For the base, it's a third the distance of the triangle. So to determine xx, that is your x-plane, it is a third the distance. So the distance is denoted from the base to the tip of the triangle right there. Alright? And then if you're doing a circle, look what you would have. IXX, hold on. And you will have to take pi. It must be pi, because you have to use the diameter now. So it's pi d4. Right, over 64 that you would use to work out it. And this is for both IXX and IYY. So right here, if I am doing a circle and I'm trying to find IXX or IYY, the value that I would substitute right here is this. Pi d4 over 64. Right here where I have the I. Right? If I am finding an allosection for a rectangle, these values, this right here, this formula right here, I will substitute it right here where I have this I. Right? So you will have this as your guide, and we will go through them, of course. So the first step, since it is the second area, bear in mind, this is the second moment of area. It means that you must find the center of gravity for each section first, right? And you must have the CG for the object. So basically you have to work out all of the center of gravity process that we've been through before, and then you can get into this step. After determining these values, look at this. We know that our y is going to be 150 for the overall, and we know that the x is going to be 100 for the overall. And then here you will see where you have the individual center of gravity values for each section. It's 3 sections for this shape, I-beam. Yeah? You're going to just plug that in. So at this point in time, you're plugging in the information. But if the information is wrong from before, you know your answer is going to be wrong. Alright, so section 1. This is my section 1. Look at how it was, where was it labeled again? All the way. 1 second. because I wanted to get this on the next side, so you don't have to go back. Pace, man, pace. It's not pacing. All right, so here we have the first section. For section 1, this is the formula you're going to use. This is the overall formula for inertia. But we're finding inertia about the x-axis first. Which formula are you going to use? You are going to use the rectangular one right here. For IXX, you will substitute 1 over 12 BD cube. So see it right there? 1 over 12 BD cube. Because it's 1 over 12, you notice that I just have the BD cube over 12. Right? That is fine. Plus area 1, open bracket. This is the total distance. You would move on your y-axis for the center of gravity, and this is y2. The center of gravity along the y-axis for section 1. Alright? After you have that formula written out, you're plugging in the information that you have. What is the base? The base right here is 200. That information is entered as 200 millimeter. What was the depth? The depth right there was what? 50. It is 50 millimeter cube. The millimeter cube, the cube is on the outside. So the 50 is cubed and the millimeter is also cubed. Good? Over 12 plus, what was the area? The area was 200 times 50, and here we got the 10,000. The overall y value obtained was this, 150. Hence you're seeing here 150 right here. What was the what was y1 value? Y1 was 275. Good? 275 millimeter. Hence you're seeing that right there. Good? Now, after you have this, all you're doing is working it out. So 50 cube give you 125. Right? You cannot work out, do not multiply before you cube it. Some persons make those silly mistakes. You have to find the cube first, right? And then you're going to multiply. You can't divide either. It's just like with this one right here. You have to do the subtraction in the bracket. Work out what is in the bracket first before, because you notice this is negative. This is saying negative 125 millimeter. But when you square it, you're going to get a positive value right here. Good? And right here you're seeing 200 millimeter times the 125. You work out what is in the bracket. You multiply, put the value right there. Millimeter times millimeter cube gives you what? Millimeter 4 to the 4th power. Yes? Why is it important that you have the units correct? Because you cannot add if your units are not the same. If you look over here, we have the area being millimeter square. This is why it's so important for you to square this value so that you can now multiply them. When you multiply values, you add the power of the units. So 2 plus 2 will give you 4. And up here, we're multiplying, so we're adding the power. So we have 3 plus 1 gives us 4. So you look in this line, you will see where our units are the same, so we can add. But before you add, what do you have to do? You have to divide. You have to apply that rule. So you divide, you get this value times this. Now this is a large value. I can express this in another way. If I wanted to express that using significant figures, what would it be? Anybody remember how to work that out? How you move the decimal point from the end and so forth? Alright. So I would say this is, you're moving it. Yeah? So you're moving from the end, and I'll go 1, 2, 3, 4, 5, 6. If I go 6 right here, then how many, what's the power right there? That's 2 how much? That's 6. That's times 10 to how much? How many decimal? How many points did I move it? 6. All right. You can also move. So you can say 1, 2, 3, 4, 5, 6, 7, 8. So you can ignore the commas that you have there because it's a large value. So you can write it out as such, or you can express it in your significance. So you can say 1.58 times 10 to the 6th and so forth, and you will get the same answer. Yeah, I don't mind if you write it out. I don't mind if you want to use that, whichever way, whichever one works for you. Now I want you to look at this page. Read, please, to ask your question. I'm not picking on you, but I just know you have questions. Go ahead and ask them. You follow. Simple, it's just plugging in.
Yes, miss. I'm following.
All right. Now, it is
Miss.
for 1. Yes, Lorenzo.
Could you just go to the diagram that the measurements were taken from, please, real quickly?
Right. Okay, hold on. See it right here. Where is it? See it right here.
All right. So the 275 that you have for the overall length on the y-axis, is that coming?
Figure 1.
For figure 1, is that coming from the center of the top to the bottom?
From the top to the bottom. Hold on, let me draw a line to show you where it's coming from. It's coming from right at that midpoint all the way to the bottom right there. Because this is section 1. But you notice that the base of it and the weight of this is the same as the one down there. So it really don't matter. But this is 25. Yeah, so half of the 50 is 25. And then what is this? This is 200.
50.
Yeah, this is 200 plus the 50. So that's how we got the 275. For the middle one right now, this right here is 200, So you will have 100, but then you have to add the 50 to go to your base. Yeah? And then for this one, you have the 25.
Okay, I didn't get to see which one of the sections you are using as 1. So
this one is 1. Maybe I should put the thing on there for you to see. Hold on. So this is 1. This is 2. And this is 3.
All right, thank you.
All right. So you notice what you find in inertia for XX for each section. So you know that you're happy to do 2 more times, right? Just for this one. So you have to find IXX2. Huh?
That is what I was looking at.
And then you go to IXX3.
And then you have YY1, IYY2, IYY3. That's what I tell you. It's simple. But it's a lot of steps. So you will just make one little mistake and then it just show you off just by looking at the value too many times. The value is too many times. So this is just 1, Now this is section 2. So look at it. Same formula, BD cube over 12, but this is now area 2. And now you're going to put in Y2. So let's look where that Y2 is coming from. This is section 2. So you'll see from the base, and it's giving you that is where the Y2 came from. So that's why we're using the 150 right here. Yeah? So you will see where 50 is the base. Look. So 50 right across here is 50. And the depth of it right here is what? 200. Hold on. 200. So it's the 200 cube. Yeah? Sometimes even that confused in terms of how you write down the B and the D. So you have to look at it over 12. Same area and so forth. And you're working it all the way down. So this would be, let's move our point. 1, 2, 3, 4, 5, 6. So you would have 33 times, let's see, 33 times 10 to the power of 6. When you put that in your calculator, you get back this value. So 33 times 10 to the power of 6. That's the value you will get. Well, you should actually have 33.33 if you want to be accurate. Because if you have 33 alone times 10, you're going to get 0, 0, 0, 0. Right? So this is section 3. So this 25. Let me show you where the 25. The 25 is for Y3. See it right there? So because that is 25 millimeter, that's why you plug it in. as 25 and you work it all the way down. And then you will find the total inertia in the x-axis is determined by summing all of what you have. So if you have, in this case, we have 3 sections, so we're going to add them, right? So you add all of those, and that will tell you the total inertia. And you make your little notation at the end. You're not finished yet, because you need to now find YY. 1 second, let me show you something. So for YY, after you find everything, this is the note. Remember that where the value is larger, that is the ability of the beam to resist the most bending. So it's either going to be along the X or the Y. So when you sum it, if the sum of IYY is higher than the sum of IXX, you would say the ability of the beam to resist bending is greater about IYY, or the axis YY. Yeah? Okay, so that's this process for IXX. Let's just look at IYY and not jump over it. For IYY, look at the formula. We're going to be using I, this is inertia, plus area, and now we're using our X values. Yeah? And these are the X values we determined when we worked out the center of gravity. Careful now, it is going to be B cube D. Earlier when we were finding IXX, remember that this is the D that we cubed. Now we are cubing what? The B, the base, and that's very important for you to note. Right? You can write it the other way or you can write it this way. Just ensure that you cube the correct thing. And then you're plugging in the information all the way down. See? Questions? Any questions?
Yes, Very minutes.
Yes, Lamar.
So for like a question like this, right? Test purposes, you would just probably give us like one question and you mark looking at the steps that we follow and not exactly the answer there.
Remember that I don't believe exam determine how much you know. So that's I'm the wrong person you're asking that. That's why you're getting an assignment for it. So I don't believe in exams, so you can't ask me that. But if I was to give you an exam, I couldn't give you more than 1 or 2 questions. That's the entire paper for 3 hours.
Oh.
So you can check over. We are being realistic. But it is you realize it finished? You realize that already gone through
this
module
is a
1.
PowerPoint or a PDF document?
It's a PowerPoint that I converted to handout PDF. It's already hold on.
I was just about to ask you to just open it, miss, because we don't have access to it yet.
You know that, miss. Okay. Show. There you go. And I'm going to open activity 1. Because we're going to do it right.
Refresh.
So we have time to do it. See? Just 2-1 here. But well, let's see if we can finish 1. We can finish the 2. It's 8:30 we finish class, right? We can finish these 2.
Just remember, say fresh in our brains.
For last week, hold on. Did we record last
Chris, you have ball already?
Let me email you there. Okay, we say let's up
week?
there.
Check it. He said check it
Chris,
was.
you have ball.
We didn't record last week because it was just the activity we did for the revision activity we did for not bending moment. What is it? For moments.
Yeah, you didn't record it.
We didn't need to record it because I wasn't even working it out with them. They were just working it and they sent it to my WhatsApp. So for those persons who didn't do it and send it to the WhatsApp, you still have to do it, because guess what? You realize that all of that is tied up into inertia. So if you don't understand that, those 2 things, it's going to affect you. Yes, dear, I remember. And I remember your message in the group to record, but there was no need to record. So you can look back at the revision, what we did in last week's class, well, the file, and try to go through to take on number 1 by, or should we do it together? We should do it together, not true? You can find the center of gravity. Find the center. You should try it. Here's the formula right here. Let's try it.
Me have something concerning the formula. The reason, because I want to understand it in the easiest way possible so I can remember. The reason why them use BD cube the x is because
Can you repeat for me, please? I didn't hear you. The reason why we're what? Repeating?
The reason why them use BD cube for IXX is because really the x have to do with the base by itself. But then use dB cube for y because I distance away from x. I mean objective.
You mean away from the base?
Right, away from.
You can look at it that way, if that is how you understand it, yes. Remember that is constant as well, but I understand what you're saying. You're saying that the D is the depth of from the base for Y, which is considered the depth right there. And then for BQ for XX, the B is of emphasis because it is from that base. Point, from the base.
Right. Okay.
So here you have them. So write it off quickly. So, Mr. Sims, I hope you didn't throw away your book. Write out the formula. See it right here, these two. We're focusing on these two right here.
Isn't that